Hi guys, so today we'll see another Leetcode problem that is in the category of strings. So let's see the question first, and after that I will see different approaches to solve this question. So the question is popularly known as the valid anagrams, and we will be given two strings S and T, and we have to return true if T is an anagram of S, and we have to return false if T is not an anagram of S. So what does anagram means? So anagram is a word or phrase formed by rearranging the letters of a different words or phrase, typically using all the original letters exactly once. So let's see the example one. So in the input, S string is given anagram and the T is given NAGARM. Basically, the length of the strings are same, and the characters which are used in the S string and the T string are also same, but their arrangement is different from S and T. So that's why the output is written true. Again, see the example 2. Their input is given RAT rate, T is given CAR, but here the length is same of both of these strings, but the characters are different, because here we can see T is present, but in this string T is not present. That's why the output is false. I hope the question is clear for you. So now let's see the approaches to solve this question. So there are three ways, or there are three major ways we can solve this question approaches. So first approach, using the count array approach, using the count character approach, not arrays, using the count character approach. Second, we can use frequency array approach, and third one is using hash map. So I will discuss the first two approach, and you have to try by yourself this third approach. Okay, so let's see the first approach first. So using count character. So basically, the using count character approach, we first of all, the first step is to sort the given arrays, both string, sort the both string. After sorting the both string, we have to use one loop to both of the strings togetherly and check each element in the both strings one by one. And the third step, we have to, if at any position the characters are found to be different, or if the length of the two strings are different, then they cannot be anagrams, otherwise they will be anagram. So if you don't understand my explanation, let me dry run it, the example with that approach, so that will be very clear, more clear for you. So we have to, first of all, we have to create to character array. We have to convert this string into character array. So when you convert this string into character array, it looks like this one. So for S, it will be A N A G R A M, and for T, it will look like N A G A R A M. So these are we have converted this string to character array. So when we sort this character array, so it will looks like something like this: A, then come G, then come M, and then R. So just ignore this space. So there are how many characters present? 1 2 3 4 5 6 7. So see that this one, 1 2 3 4 5 6 7. So we are correct. So after sorting the S string or the character array, so we have to sort this T character array. So let's sort this character array. So it will give the same result like Z, M, and R. Why it will give the same result? Because the same characters are present in the T string. So just their positions are different, but the same characters are present and the lengths are equal. So this is the simple approach. So if these are the if these two properties are fulfilled or true, then we have to return the true. So here that's why the example 1 output is true. And if you run the example 2, we'll get that the characters are different, although the lengths are equal. So that's why the output is false. So this is the very simple approach. So now let's see the next approach, frequency character array approach. So this is our second approach. So for this approach, I have already created one array which size would be 26. So this array, let's rename it alphabet. So our array name is alphabet, which size would be 26. So after that, after creating this array, what we will be doing, we will be traverse the S string first. So the moment when we traverse the S string, we will be doing one thing. We will be storing the frequency of every character in this alphabet array. So how we will be doing this? That s dot char at ith index minus a. So I have discussed this thing in the previous video, so you can watch that one, but I will again discuss it here. So in this approach, we need ASCII value of every characters. As the letters are small letters, so we know that the ASCII value for A is 97, B is 98, and it will goes up to Z. The Z of ASCII value of Z is 122. So now let's traverse one by one. Let me remove these things. Okay. So now let's go to the A. So for A, the ASCII value is 97. So when you do this 97 minus 97, we will get 0. So the location of 97 in the alphabet array would be here. So let's increase the count here, 1. So now again check for the character N. So go to the next character, that is N. So ASCII value for N is 110. So minus 97, that will give us 13. So the location of N is in the 13 index. So this should be here. So let's increase its frequency, 1. So now again we will be we'll get A again. So the frequency here, just increase its frequency 1 to 2, because we have encountered the array previously. So the updated frequency would be 2. Again we will be will get G. So the ASCII value for Z is 103 minus 97. So location would be 6th index. So the 6th index is here. So let's increase it 1. So again after that we will get R. So ASCII value for R is 114. Yeah. So minus 97, that will give us 17. So the location would be in this index. Let's increase its count or frequency, 1. So now check for A. Again A, the increase its frequency to 3, and for M the frequency would be 109 minus 97. So 12. The location would be in the this. So increase it 1. So when we finish the traversal of the first string, then we will traverse the second string. The second string is t. So and when we traverse this second string, we will decrement the value. The frequency value will be decrementing one by one. So let's see, the first character is n. So n, where is our n? Location of n is 13. So where is the 13? So just reduce it to 0. Again see a. So for a, reduce this to 2. So this 3 will reduce up to 2. So again go to next character. This is z. The location of z is 6 position, 6 index, yeah, 6. So reduce it to 0. So after doing this all things, we will get everything 0 0 0 0. It means our array is empty and our both of these strings are anagrams. True. So that is the main intuition or the approach behind this logic. So let's see the code now. So for approach 1, we have created 2 character array. Let me select this. Yeah. So for string 1, we have created string. For the string s, we have created this character array. For string t, we have created this character array. Then after that, we have sorted those things, and then we have checked that whether these character arrays are equal or not. If it is equal, then we will have to return true. If it is not, then we will return false. So now what is the time complexity? The most important thing comes into our mind. So what will be the time complexity for this approach? So it will take order of time complexity for this approach is order of MlogM plus order of NlogN, and the space complexity would be how many spaces? Order of 1, constant space. So this is the first approach code. Let's see by running it one. So now run this code. Yeah, it's running. Let's submit it. Yeah, it is submitted successfully. All right, so now check the next approach, I mean the frequency array approach code. So we first of all we will be creating one alphabet array which size would be 26. Then we will be traversing the first string and we will store its frequency in this alphabet array. So secondly, what we will be doing, we will be traversing the second string and we will decrement its frequency. Then we will check that whether the I equal 0 or not. If I not equal 0, then we will return false, and if I equal 0, then we will return true. So now the time complexity for this approach would be order of n plus m, and the space complexity would be order of 26. Why 26? The size of the letters. The size of the letters means these small letters up to A to Z, whatever present. So that's all for today. I hope you understood this approach, both of these approach, and I highly recommend you to go through the hash map approach. This is almost similar to this approach too, just we have to create one hash map and we have to track its frequency and check whether this frequency are 0 or not after traversing both the string. So I hope you will be able to do it. So that's it. Okay, bye.